Guys, Mrs. Trader here. Today we're going to talk about trigonometric application. Nope. Hey guys, Mrs. Trader here. Today we're going to talk about trigonometric applications. Our learning target is you'll be able to use sine, cosine, and tangent to solve story problems. And you know you'll be successful when you can make a diagram and a picture to solve for missing sides or angles using our trig functions. Let's jump in and review a little bit of SOHCAHTOA first. So if we were being asked to solve for the missing angle in this problem, what we'd first want to do is label our side. So let's do that. Across from our question mark angle, which I usually call it theta, so I'm going to put that in there. Across from our reference angle is the opposite side. Across from the right angle is hypotenuse, and the last one's adjacent. In this problem, it looks like we have H and O, which is a sine problem. So I'm going to set myself up. Sine of my angle theta is equal to opposite, or 19, over hypotenuse, 27. At this point, we want to do inverse sine to both sides, so I'm going to end out with theta on the left and inverse sine on the right. What's on the right will then go right in our decimals calculator. Let me pull that up. What you'll have to do when you're on there is go to the functions key, inverse sine, and we had 19 over 27, which gives us 44.7. Throw in an approximately, and then you'll be good to go. Let's try a story problem with a similar situation. So I'm from Michigan, and a place that we always love to go is Empire, Michigan. There is a place called Sleeping Bear Sand Dunes there, and basically you can hike up this mountain cliff, and it's by a large body of water. So what you can do is from the top, you can look down like this, and you can see the water, and people try to fend for themselves and go down this hill, and then they have to climb back up. Over time, erosion has taken place due to the humans who walk down it and slowly push the sand at a steeper and steeper degree. So when you get to the bottom, as you can see, this guy over here, he's regretting his life right now, as I would like to say, because he now has to climb back up that cliff. So going down is hard enough, but getting up is even harder. And the beach is essentially all gone now due to erosion. So they used to be able to perform rescues on the beach by having a boat come up and pick you up and then take you to land in a different place. But that's no longer an option, seeing how it's too steep. So there's actually a sign that's up if you're at the top that says don't risk injury and rescue if he's going down. It might take 2 hours to climb back up. So my problem here has to do with this situation. I want to know how steep it is. So this is information that I found on Google and probably has changed by now due to the fact that it erodes day by day. At this point, though, Sleeping Bear Sand Dune Cliff was approximately 234 feet tall, and the distance from the base of the cliff to the water was 278 feet. If you were to climb the cliff, if you had gone down it and then climbing back up, at what angle of elevation of steepness would you have to climb back up? So these are situations that are basic with trig applications, and we always want to start with drawing a picture. So I'm just going to know that it's a cliff and kind of get an idea of the cliff. So like this isn't going to be beautiful, but here's the cliff and here's the water. And I'm going to end up wanting to know the angle that I'm climbing up. Like normally I walk on flat ground, but I want to know that angle up, like that degree measurement. I know some other information. I know the height of the cliff, it said, so I'm going to draw a height in. I know that's perpendicular to the bottom. If I cut through the ground there, the height was 234. And the base, from the base of the cliff to the water is 278 feet. So I've got a lot of good information here, and obviously we can see we've got a little right triangle peeping out. If I label my sides, I have an opposite side and an adjacent side, which will be a tangent problem. So let's do that. We've got tangent of my angle, which I don't know yet, I'm going to call theta, is equal to opposite, 234, over adjacent, 278. To undo tangent, we inverse tangent both sides. So I'd have theta by itself on the left, and I have had inverse tangent on the right. This will then go in our trusty decimals calculator. From here, we're in the function key. We'll hit inverse tangent, and we had, what was it? 234 over 278. 234 over 278. Whoa, that looks crazy. Let me try that again. 234 over 278. So it's supposed to show that it's kind of cool because when you hit the divide button, it automatically makes it a fraction, which is kind of cool. Our answer here is about 40.1 degrees, approximately 40.1 degrees. Now, this seems fine, but let's think about it in context for a minute. You are having to climb up at an angle of 40 degrees-ish. Like, how steep is that? Here is a representation of it. So here would be you walking straight. You have to climb at this angle. That is very steep. That's why that guy was climbing with his hands and his feet. We have 2 more story problems. Let's jump into the next one. I want to know about this balloon. I drew a nice little picture of, I didn't draw it, I clip arted a picture of this. It says you're standing about 50 meters from a hot air balloon that is preparing to take off. So here I am, and I'm standing about 50 meters away from it. And it started to take off, and the angle of elevation from my line of sight, so normally I look straight, but I am looking up at the balloon, is 28 degrees. Now this is a pretty crude drawing, but we'll be okay. I want to know, how tall is it? So I don't know this height. It looks like, again, I have an opposite and adjacent, another tangent problem. So let's set ourselves up. Tangent of my angle is 28 equals opposite, which is x, over adjacent, which is 50. To get x by itself, an undo division, we will multiply both sides by 50. So the 50s cancel. And in my calculator, 50 tangent 28. Oh, that looks scary. Let me try again. 50 tangent 28, which is about 26.58, so about 26.6. So that height is about 26.6, which makes sense to me because that's probably about how tall the balloon is in and of itself, and maybe it started rising a little bit. Here's our last one, Circus Dimensions. The circus is in town, and you are part of the crew that is setting up an enormous tent. The center pole that holds up the tent is 70 feet tall. Okay, let me pause for a minute, and I want to start drawing my picture because this is a lot of sentences, so I don't want to get lost. So here's my center pole, and I'm just looking at part of the tent like it comes off over here too. But that pole is 70 feet tall, and I'm assuming it's at a right angle. To keep it upright, the support cable, so I guess here's my support cable that I drew in, needs to be attached to the top of the pole. I did that. So it forms a 60-degree angle with the ground. Okay, so here's the ground, and here's my 60-degree angle. How long is the cable? Okay, so let's stop here, and let's solve this part. I see there's more of the problem, but I want to pause right here and get this answer first. I'm going to label my sides. Across from the right angle is the hypotenuse. Across from my reference angle is opposite. So that would be a sine problem. So sine of my angle, 60, is equal to opposite, which is 70, over hypotenuse, x. When x is on the denominator, we know that we're going to cross cancel and simplify this by switching the x and the sine 60. So I'd have 70 over sine 60. And that'll go in my calculator. Over sine 60 is about 80.8. About 80.8. All right. Now we've got more to our problem. I don't want to forget about that. So let's move on. It says, how far from the pole should the cable be attached to the ground? So how far from the pole, here's the pole, should the cable be attached to the ground? So I've got a new thing to solve for, y. And I actually have lots of options to solve for y. I could use a trig function again, or I actually could just use Pythagorean theorem. We're pretty good at that, so let's kind of switch spaces and do that. I've got A, B, and C, my hypotenuse. Lots of labels going on here, but I tried to color coordinate. So A squared plus B squared equals C squared. So I've got 70 squared plus, we don't know y, so y squared equals, I would say x squared, but we found x to be 80.8. 80.8 squared. Let's subtract 70 squared from both sides. And then I would square root both sides. So I'd have the square root of 80.8 minus 70, and they're both squared. Let's put that in our calculator. It can handle all of that at once. Going back to my set of main functions, I'll do square root, and I had 80.8 squared minus 70 squared. It gives me about 40.4. So there is my final answer, about 40.4. And each of these I should write in were feet. That's all I've got for today in solving equations when we are looking at trivial applications. You want to make sure you draw a picture, label your sides, and move on like normal from there. I'll see you next time, guys. Bye.